for notes anyway, and I'm already cutting one out, so I think we're gonna make it. Thinking this is pre-planned notes for star delays. I was just thinking last week, oh, it's so great. Normally I'm teaching trig through awful star delays. How great it is that the weather is so great. And then I just myself down. Trig's usually rough for people anyway, and then go into our delays, or we just get 20 minutes at a time. This is just review of geometry, right triangle trig. If you have a right triangle, then you can find these trig values based on the sides of the triangle. So you just pick one of these angles are called theta. It doesn't matter which one, because the ratio is the same, whichever way you label it. I'm going to call this theta. So just know you can call that one theta too, but pick one of them and label it theta. And we know the side across the right angle, what's that called in the right triangle? Hypotenuse. The side across from it is the side opposite. And the side that's not the hypotenuse and not the opposite is right next to it. We call that the adjacent side. Adjacent must be next to the person sitting adjacent to you. So I just abbreviate these. And so we can talk about that these are these trig functions, and these are the shortened versions of them. But just to remind you that this is not pronounced sin, it's sine, because it's really spelled S-I-N-E. But on your calculator, only 3 letters fit, so it's just S-I-N is our shorthand for it. This stands for cosine. And this stands for tangent. There's some terrible math joke about it. Tangent. I can't even tell you, that's the punchline. So he's a tangent, but I can't remember the beginning of it, so it kind of just blows the whole joke, right? But SOHCAHTOA, did your geometry teacher teach you this? Because sine's ratio is the opposite side over the hypotenuse. Cosine is equal to the opposite side divided by the hypotenuse, S-O-H, that's where the so comes from. Cosine is adjacent over hypotenuse. Where the H comes from. And tangent is the opposite side over the adjacent side. And again, depending on what angle you're looking at, depends on what is your opposite side. But in geometry, they kind of left some stuff out. There's actually 3 more trig functions, which are the reciprocal functions of sine, cosine, and tangent. So we also where we do. We also have this, which stands for cosecant. It's all underneath there. Cosecant. And here's what's great. If you know SOHCAHTOA, it's not hard to do these. They're just the reciprocal of each one of these. So the reciprocal of sine, you just flip it over. So that's just hypotenuse over opposite. Just learning the new names of it. And then, this is cosecant, this is just secant. We abbreviate just the first 2 letters, and it's the reciprocal of cosine, so that's hypotenuse over adjacent. And the last one's the easiest to remember, because the reciprocal of tangent is called cotangent. And so it's going to be adjacent over opposite. And people always try to come up with, well, if we do SOHCAHTOA, why don't we just make up our own little thing for this? But it never works out very well. But you can try it. It would be CHO, cosecant and hypotenuse are opposite. Secant, hypotenuse over adjacent, and cotangent is adjacent over opposite. Shoshakow. I'm pretty sure Grady still says this all the time, is what my college algebra kids told me, that he says this, which I find silly. I always just say it to be funny, because kids always want to do it. But to me, just do SOHCAHTOA and then flip them all over, and then you have the other three. Okay? So, let's practice. And again, I'm just picking one of these. Maybe on your homework, it'll say find the trig functions for both acute angles, which means instead of 6 things in one, it gives you that. Like for 12, that's the case, right? So notice that again, I really want to take that down here. Right triangle, so that's the right triangle. If I'm doing right triangle trig, I've got to know all 3 sides of this triangle, but they only give me 2, so how do I find the third side? Pythagorean theorem, right? So, you're going to realize in trig very quickly, we use Pythagorean theorem all the time. So remember that the 2 shorter legs, a squared plus b squared, should always add up to the hypotenuse. So this would be 5 squared plus b squared. That's 169 minus 25. I believe is 144. That works out super nice. Yeah. The third side of that triangle should be 12. Once you know all 3 sides, you're just using the formulas that you have to know. So I'm gonna write out sine equals cosine equals. Notice when I say it, I don't always say the word theta, but I always write the word theta. You can't have sine by itself. Sine of what, right? Cosine of what? And sometimes there'll be 2 different angles, and they'll be labeled a different way. So how do you show what you're taking the sine, cosine, or tangent of? You have to put the angle there. So sine of theta equals cosine of theta tangent. And then again, we're just using our SOHCAHTOA. So sine is opposite over hypotenuse, and we're just going to leave it as a fraction. So 5 over 13. Cosine of theta is adjacent over hypotenuse. So that's 12 over 13. And tangent is opposite over adjacent. Again, this one would be 5 over 12. For me, I always do these 3, and then I do the reciprocal functions without ever looking back at the triangle, which means the bad part about that is if I mess these up, I'm going to mess these up. But for me, it's just easier to remember. I'm just going to flip them over. Also, you have to remember which ones go together. So, cosecant goes with sine, and secant goes with cosine. So cosecant, secant, and then cotangent. For me, I always remembered when I first learned these that this made no sense to me. I was like, why doesn't cosecant go with cosine, right? That seems like that should make sense. So I always remembered it made no sense. Like, it was the opposite of the way it should have went in my head, and that's how I remembered which one went with which one. Or maybe you can just remember the essence, like they don't go together. A way to remember. So we're just going to flip them over. So I'm just going to say this is 13 over 5, this is 13 over 12, this is 12 over 5. Questions about that? Two and 2/5 is the same thing as 12 over 5, but improper fractions are just better in higher math, and so I always keep it as an improper fraction. If you change it, I wouldn't have marked you wrong. There's just no need to change it. Okay? What else do we do? What if they gave you this instead of a triangle? Find the other 5 trig functions if the sine of theta equals 2. do we know if they tell us the sine of theta equals 2/3?
Yeah, because we know that sine is opposite over hypotenuse.
So kind of just like the last one, are they giving us 2 of the 3 sides of the triangle? Yeah, so for me, it makes sense to draw a triangle.
No, they didn't do one.
Just kind of change things up. You definitely call theta down here. But just to show you, it doesn't matter where you put theta as long as you label it correctly. So I'm going to put theta up here this time. But now that means if theta's up here, then my opposite side is down here. Okay? So if you put theta over here, then the opposite side just across from the angle that you labeled. And that hypotenuse is always. And the picture is just there to help us. You can definitely see that I'm probably not Pythagorean theorem. So, I don't know about you, but to me, I just kind of do that in my head. I mean, I still write it down, but I don't write 2 squared plus what squared equals 3 squared. In my head, I realize that I'm going to always take this squared minus this squared, on no side. So, like, I'm going to write 9 minus 4 equals 3 squared. So I'm kind of in my head realizing that I'm going to always subtract that over to save myself some time. So that means 5 equals b squared. I do not want decimals, all right? We want exact answers here. So we're going to say that b equals the square root of 5. So don't give me decimals on this when they ask for the value. And I'll say things in the directions. I'll say give me the exact value, which means not decimal. Now that we have that, it's just like the last one, except that they already gave me sine. So I'm just going to start with cosine. So cosine is adjacent over hypotenuse, so that's going to be the third of 5 over 3. And tangent is opposite over adjacent, so that's going to be 2 over square root of 5. And I want to talk about this for a minute. When I was in school, you never left square roots in the bottom. And if you think about what we do in Algebra 2 and even what we've done in the beginning, first semester of this class, we usually rationalize our denominators. I think it looks nice. I think it makes them all look the same when we rationalize it. But there's this big debate among math people. I know that's pretty exciting debates among math people. But do we need to rationalize denominators anymore? Is it something that we did 50 years ago because everyone didn't have a calculator that they could just approximate the value? That's why you rationalize denominators. So some people say there's no need to rationalize denominators because we have calculators now. Like, we all know it's the same thing. It's not a big deal. If you look in the back of your book, for trig stuff, your book does not rationalize denominators. Like, they would read this as 2 over the square root of 5. Some math people, still rationalize it, and some of my math books still rationalize it. So I don't care which way you leave it, okay? I'm okay if you leave your answer like this, but I also want you to know it's the same as if I multiply the top and the bottom by the square root of 5, and I wrote the answer as 2 square root of 5 over 5. I need you to know that this answer and this answer are the same, alright? So I'm never going to make you rationalize it, but on a multiple choice question, if it's rationalized, I don't want you to freak out because you don't know that it's rationalized. Or if you go to college and you take a trig class and they make you rationalize it, I don't want you to not know that those are the same. So, just so you know that both of those answers are the same. And then flipping them over, cosecant, secant, cotangent. So cosecant is the reciprocal of sine, so that's just 3 over 2. Secant is the reciprocal of cosine, so that's 3 over the square root of 5. Or you're going to see if you do start rationalizing it, you'll just start doing that in your head, because all you do to rationalize is you multiply the top and the bottom by the radical. So it's like the radical just moves to the top, and then the bottom is just the square root of 5 times the square root of 5, which is 5. Again, both of those are okay answers. And cotangent, I'm going to rationalize this one. It's much easier if I go back to this where I just flip it over, and I would get the square root of 5. over 2. Which is the same thing you get if you flip this over and you rationalize it again. Alright, so I just kind of be aware of that as you're looking in the back of the book. Sometimes we rationalize it, sometimes. Kind of a big idea today. Hopefully it's kind of not that mind-blowing since I did do SOHCAHTOA in geometry class. The one other thing I want to do today is that you can do trig functions on your calculators. So if you do not have a scientific calculator, I need to give you one. First thing to know, your calculator will do radians or it will do degrees. So you have to make sure you're in the right mode. If you're in the wrong mode and you get the wrong answer on the test, so on most calculators, as soon as you turn it on, like on my calculator, it either says RAD at the bottom or DEG at the bottom. And until you're doing trig, you never really think about it because it doesn't matter unless you're doing trig what mode you're in. If you want to change modes, on my calculator, it's right next to second, and it's VRG. On a lot of your calculators, will be under mode. And under mode, you'll see DEG, RAD, or just the letters VR, EG, Alright, so on the question like number 3, the sine of 16.35 degrees, you have to make sure you're in degree mode first. So mine's in radian mode. So I'm going to click that, and I'm going to arrow over to degree. Now it's at the bottom. And the great thing about most calculators these days is you just hit that button, hit sine, it puts a parenthesis, and you just type in 16.35. You don't have to put the degree symbol because you told the calculator already to do degree mode. It's just like everything we do on ours, if you're not putting anything after it, you don't really have to close the parentheses. If you're going to do something outside of taking the sine of that, you use the parentheses for sure. But if you just type that in, sine of 16.35 degrees, you get 0.2815 if we're going to 4 decimal places. So, on your test, on your quiz that we're going to have, part of it's going to be without a calculator, and part of it's going to be with the calculator. And the with calculator part is definitely going to have a couple questions, making sure you can type things in your calculator. Now, look at number 4, 2 issues. 1, this is not degrees, right, because there's no degree sign. So step 1 is change the radian mode. So I'm going to move over and you have either R or RAD. Step 2 is there's no cosecant button on the calculator. There's no secant button, there's no cotangent button, because it's just the reciprocal of those functions. So if sine and cosecant are reciprocal, reciprocal means you just flip it over. So is that the same as saying cosecant is the same as 1 divided by whatever sine is? Do you agree that that means reciprocal? So no calculators, like not even graphing calculators, they don't have cosecant, secant, and cotangent buttons because they don't see a need for it. So all you have to do to find cosecant in radian mode is you're going to type in 1 divided by sine of that number. Because it's reciprocal. It's reciprocal of something. You can take sine of 3 and then do the reciprocal of that number. But to me, it's reciprocal. So in radian mode, I'm going to get 1 divided by sine of 3. And I got 7.0862. If I pronounce it 4 decimal places. When you find these numbers are not in radians or degrees. Like this is the value, the ratio there. So you don't put any like degree radian thing there. But it's just these are in degrees or radians. So really important that we're able to use our calculators. Back in the day, like not that long ago, I mean, I guess I'm kind of old, but when I was in school, the back of every trig book had a table, and it had approximate values for angles like this, because not everyone had a calculator, and they called those trig tables. If you ask your parents if they took Algebra 2 or precalculus about trig tables, they probably all use trig tables because they didn't have kind of time to do this. You had to like look at a table and you had to find, they just had like sine 16 degrees and sine 17 degrees, and you just had to like 16.35, it would be like maybe 1/4, like 4 decimals, like they were all 4 decimals, and you could do it a little bit more than that. So part of your homework today is using a calculator. If you don't have a calculator and you have a study hall later and you want to come borrow one from me, you can. If you have an iPhone or any kind of smartphone, those buttons are on there, sine, cosine, tangent, on the calculator button, or at least on my iPhone it is. There's free apps of calculators. You can find a calculator online for free as well if you don't have a calculator to use. So, this is what it says for 4-2 day 1 on your homework. We're skipping the middle ones right now. 19 through 24 all, not doing those yet. So 3 through 18 multiples of 3, those are using the SOHCAHTOA. 30 through 40, I believe, are just using your calculator. So if you don't have a calculator, if you want to start with those, or come in and borrow one. It's really okay with that. Those are all just make sure you're in the right mode as you do those.